Continuing in 4.7, we're ready for example 4. And the ones we're working on now is 0 times infinity or infinity minus infinity. You can still use L'Hopital on it, but you have to do a little bit of rearranging to make it work. So let's do the 0 times infinity first. They want us to find the limit as x approaches infinity of x squared, the sine of 1 over 4x squared. So if I stick infinity in here, we get infinity in the x squared. We get infinity in the x squared, but we get the sine of 1 over a huge number. 1 over a huge number is basically 0. So the sine of 0 is 0. Now the way we fix this is we move one of them. So in this case, I'm going to decide to move the x squared, and I'm going to rewrite this as the sine of 1 over 4x squared over, if I bring it down, it would be x to the negative 2, but I'm going to write it like that. Now when you stick an infinity, you get infinity on top, or 0 on top, and you get 0 on the bottom. So now we can run with L'Hopital. So the goal here is to fix it so it meets the 0 over 0 or the infinity over infinity. And I could have moved the sine one, but that would just look really weird with a 1 over and then a sine with another fraction in it. So it's your choice which one you move. I chose to move the x squared. It looks a little easier to me. So the derivative of the sine is the cosine of 1 over 4x squared, but that's junk. I've got to hit the derivative of that. And the derivative of that would be, I'm going to take a little detour here. Over here on the side, I'm going to write 1 over 4x squared is the same as 1/4 x to the negative 2. So its derivative would be 1/4, 4, there we go. Pull the negative 2 in front, x to the negative 3, one less power. All over the derivative of x to the negative 2, which is what that guy is, would be negative 2 x to the negative 3. Okay, so if I simplify this mess, nice things happen here. I don't want to write on it because it messes everything up. But the negative 2's are going to cancel. The x to the negative 3's are going to cancel, and I'm going to be left with a 1/4 and then a cosine of 1 over 4x squared. Okay, so now I'm asking, what is the cosine of 1 over a huge number? So I'm actually figuring out what is the cosine of 0. Well, the cosine of 0 is 1, so the limit is 1/4. Number 5. Find the limit as x approaches infinity of x minus the square root of x squared minus 3x. Now usually when you see problems like this that are infinity minus infinity, they tend to be fractions. And so if I had two fractions who gave me infinity minus infinity, I would just find a common denominator and then work with the problem. In this case it's a little different, so it's a good example to do. If you look at the square root, I need to factor out the x so that I can make a quotient. I have to have a fraction in order for L'Hopital to work. So what I'm going to do is I'm going to factor an x squared out of, and I'll take extra little steps here to show you. I'm going to take the square root and I'm going to factor an x squared out. So I get 1 minus 3 over x. Now, the square root of x squared is just x, so I can pull that out of there. I never checked it. Let me look. Sticking in infinity, yes, I get infinity minus infinity. Okay. So now if I pull that x out, and I'll take one more extra step, and then I can pull the x out of the whole thing, have the x out here, and then 1 minus the square root of 1 minus 3 over x. Now, at this point, if I plug in infinity, I get infinity And then over here I have, this piece gives me infinity, the x. The square root, if I put 3 over infinity, that's 0. 1 minus 0 is 0. Square root of 1, 1 minus 0 is 1. The square root of 1 is 1. 1 minus 1 is 0. So now I have met the infinity times 0 rule, or 0 times infinity. So I have to pull somebody downstairs, and I'm going to pull the x. Comes out as an x to the negative 1, which then pulls it down like this. So now if I check it, I get 0 over 0. Now you could tackle this next thing many different ways, but one of the easy ways is to make a substitution here. You can say, let t be 1 over x. When you do that, your limit is going to change from x goes to infinity to t heads to 0 from the right side, because you're flipping everything over. And if you flip over infinity, it becomes 0, but it's from the right side because it was a positive infinity. So doing that, it kind of simplifies the mess here. Now we're approaching 0 from the right. This turns into 1 minus the square root of 1 minus 3t over t. So now I'm going to do L'Hopital on it, because it's still 0 over 0. If it's not 0 over 0 when you make that substitution, you made a mistake. So the derivative of 1 is 0, minus, that is 1 minus 3t to the 1/2. So 1/2 in front, 1 minus 3t to the negative 1/2, times the derivative of the junk, which is negative 3, all over 1. If I clean that up, I get 3 over 2, the square root of 1 minus 3t. Now if I stick in 0 from the right side, which doesn't really matter, I'm going to get 3/2. So there's the limit. Now there are some pitfalls using L'Hopital, so make sure you read through page 250. Some weird things that can happen to you. Make sure you're simplifying as you go, because sometimes when you use L'Hopital, things get really cumbersome, like that one with the tangent and the secant. And by simplifying it, you find out that L'Hopital doesn't work again, and you accidentally use it again when you shouldn't. So make sure you're simplifying each time. This concludes section